Hello guys, welcome back to my channel, Maths on African Motives. Still working on A-level maths, and in this platform guys we shall be focusing actually on coordinate geometry. Yeah, there are some of the things that I need us to focus on so that we can actually understand the concept that we have. So I've got a lot of questions that I just want us to work on, but before we do that, I just want us to see just a basic part on the notes that we have. So guys, I'm not going to write this down, I'm just going to show you so that you can at least write down. Maybe they can help you, I don't know, if possible. So on coordinate geometry there, actually you'll be working with points. That's the major part that you'll be given, working with points and so forth. So in this case, I have this part where you will be given let's say a point A, that is the one that you're working with, and the point B. And normally I'm just going to take the point A as the first point, which is x1 y1, and the second point, which is B, as x2 y2, like that. So let's say they are located like that, and there is an angle theta, which is the angle of inclination, this one, which is the angle between the line and the positive horizontal axis, that is the angle of inclination there. So that one I'm going to talk about it later on, as we are going to work with questions. So what you need is the length of a line AB, which is actually the distance. So this length of a line is also the distance from A to B, which is given by this formula, or it can be x2 here. So take note here, you can actually write this as x2 minus x1. It's still one and the same thing. So what I'm simply saying is that the length of AB can be written as x2 minus x1 squared. What is just important there is that you are subtracting the values of x and you square them. You are subtracting the values of y and you square them. That is what you have. And the midpoint is simple, one and the same thing. You can write it as x2 plus x1, y2 plus 1, then you divide by 2. That is the midpoint, where you are given 2 points on a line. The midpoint, that is the center. Okay, then from that concept now we are going to know that the gradient of AB, since we said this is the gradient, is equal to tan theta. So tan theta is from the angle of inclination. So what I'm simply saying is that tan theta is equivalent to gradient, which is tan theta is equal to m, where m is the gradient. So that is the concept there. So that means to find theta, you shall use arctan m, like this. You have got the theta now. Okay, that is what you have. Then the equation of line AB, you know that the equation of a line can be given by this format, where m is the gradient, or the equation of a line can be taken from this: y is equal to mx plus c, where m is the gradient and c is the y-intercept. So this is our gradient and this is our y-intercept, which is the value of y when x is equal to what? When x is equal to 0. That is the concept. So there are so many things that we can actually talk about. So in this case, like I said, I just want you to show the basics that we are going to work with. And all right, then we are going to talk of lines. If two lines are parallel, they are going to have the same gradient. So if lines are parallel, they have got same gradient. If they are perpendicular, the product of their gradient is -1. So what I'm simply saying is that since m represents the gradient, if the first line has got a gradient of m and the second line has got the gradient of m2, if the lines are parallel, let's say we've got OA, the line that we are talking about, maybe which is parallel maybe to line BC. If these two lines are parallel, it means that they have got same gradient. So the two are going to have gradient, which means I'm saying the gradient of line OA will be equal to the gradient of line BC. All right, which is if these two lines are perpendicular. Now maybe we're talking of perpendicular, therefore the product of the gradients should give us a -1, which means the gradient of line OA times the gradient of line BC is going to give us a -1. So by doing this, we can formulate a lot of things there from the equation of a line. Remember, you can state this. I'm going to explain all these, and also I want you to take this part in your notes also, that whenever you are finding the point of intersection, let's say for these ones we're talking of two straight lines, A is the point of intersection. So to find the point of intersection, you solve the given equations simultaneously. You'll be given this as an equation of y is equal to f of x, another one maybe y is equal to g of x, like that. So you solve the given equation simultaneously to find the point of intersection, because the point of intersection, you've got x and y like there. So the value of x that you find and the value of y, that's your point of intersection. So when you are talking of a curve, which is a circle, is the same thing. To find the point of intersection, it can be a quadratic graph that you are given. There can be a point of intersection with a line. So to find these 2 points of intersection, you solve the same given simultaneous equation. Maybe there is a function of y is equal to x squared and a line of y is equal to x. So all that you need is to solve, because you shall have your y is equal to x squared. Let's just say this is our y is equal to x squared, like this, and this is our y is equal to x. I don't know if it is going to pass like that, so something like that. So that is the concept that you shall have. Y is equal to x, y is equal to x squared. So you simply solve the given equation simultaneously. So like I said, I shall explain more about that one. Okay, just an understanding of a straight line before we move on to the questions. I just want you to know about the straight line, because you might be given a straight line given the equation which is of the format y is equal to mx plus c. Okay, or it can be written in this form: ax plus by plus c is equal to 0, or this can be written, some they can even write this as is different from the source that you are using. So these are the typical equations of a straight line that we have. And this is the gradient intercept format. This format that we have is called the gradient intercept. That's our gradient intercept format, where I told you that m is the gradient and c is the y-intercept. So that means if you can write your equation like y is equal to 2x plus 3, it means here your gradient is equivalent to what? Is equivalent to 2. That is the gradient of the line. So that can actually help us to answer a lot of questions. If you are given the equation, all you need is to change and make y to be the subject, then the number that is going to affect x is your gradient. That is the concept. So because they are going to ask you if the lines are parallel, all you need is to make sure that their equations are written in the same format, like that. All right, so I am having these questions, guys, that I'm going to start with. We are given in this part a question that is at the points P, Q, R. I have got the coordinates 3, -1, 2, 5, and 3 respectively. So that actually means this is our point P. This is, because if they say respectively, that means this is our point P, our point Q, and this is our point R here. So these are the points that you're given respectively. Find the equation of the straight line joining P to the midpoint of QR. Guys, this is something very, very important. All right. Let's say we want to take note, guys. We want to find the equation of the line that is joining P, which means P is a point and QR is a line. So let's say this is our point P here to the line QR. All right, this is the midpoint actually that we are talking about. It's not that it is perpendicular, no, it's just going to be at perpendicular it's going to be the midpoint, this one. So I'm saying, let's say this is your point P here. All right, because we are joining P to the midpoint of QR, which is a line. The QR is a line. So let's say this is your QR. All right, so this is my point Q. Remember, I'm given the coordinates here, so I'm just going to indicate these coordinates, which is 3 -1 on P. This is 3 -1. This is just a sketch, guys. All right, Q is 2, 5. This is my Q here, which is 2, 5, and this is my R here, which is 8, 3. All right, so this is what you have here. So this is your M, which is the midpoint, okay, of this line QR, because we are told that it is connecting this. We want the equation from P to the midpoint, because all that we just have here is the point P, so we can't determine the equation because we want the equation of this line. So how can we find the equation of this line? All we need is to know this point here, which is the midpoint of QR, so that we can use now these 2 points to find the equation of a line, because once we've got 2 points, the equation of a line is possible now to be found. So all we need is to find the midpoint, and from our notes we say that the midpoint, we are going to add the values of x together, then we divide by 2. All right, we add the values of y together, then we divide by 2. That's the midpoint of a point. So which means the midpoint of QR is the one that you're talking about here, which is Q to R here. So this is your x, you can just say x1, y1. This is your x2, y2. So you add 2 plus 8. So you're going to add for x. This is your midpoint, 2 plus 8 over 2. Okay, then the values of y here, that's 5 and 3. So it's going to be 5 plus 3 over 2. All right, so this is our midpoint, which is going to give us something like 5 here, and this is going to give us 4. All right, so that's our midpoint M, which is 5, 4. So now we want to calculate this equation. So it's now easier to calculate the equation of what? Of PM, because the equation, we know that is simply, for you to have the equation, you can write it in the form of y is equal to what? Mx plus c. So that means we have to find the gradient from P to M, of which the gradient is equivalent to the change in y over the change in x. So in this case, we can just name our points. This be our x1, y1, x2, y2. We are now focusing with these 2 points because we want to calculate the equations from P, the equation from this point P to the midpoint, this one. So we are focusing with these 2 points. All right. So that's y2 here, which is according to my point is going to be 4 minus. So it doesn't matter, you can even start with this one. So but according to my illustration, I have used this as my y2, so it's 4 minus 1. So your calculators, guys, they are good at simplifying all these, so don't worry about this. 5 minus 3, your calculator is going to simplify everything for you, and that's going to give you a 5 here. So this is your gradient of the line from what? From P to the midpoint. So if this be our gradient, and we said our equation can be written like y is equal to mx plus c, where m is our gradient, therefore y is equivalent to 5x plus c. So what is left is to find this value of c, which is the unknown. So what am I going to do to find this c? I'm going to substitute any of the given points that are on the line that I'm finding the equation, and on the line that I'm finding the equation is this line here, which is P to M. So I'm going to substitute any, either this point P or this point M. Okay, so in this case I'm going to take this point P, right, which is 3 minus 1. So substituting the point P, which is 3 minus 1, this is your x and this is your y. So you substitute in place of y here, which is minus 1, is equal to, in place of x, your x is what? Your x is 3 plus c, that's 5 times 3, which is something like 15. Then you transpose there, it's going to be a negative, which is negative 16. That's minus 1 minus 15, guys. Okay, if you are not actually mistaken there. All right, that's what you're going to have. So on the gradient part, this is actually 2 here, 5 over 2. I think someone actually saw this and said, what is this guy doing? Okay, this is 5 over 2 here, because I'm seeing that here there's a thought like it's a 5, it's a 4, I mean, so it's actually 5 minus 3, which is 2 here. So guys, just correct this. All right, but I hope you're together there. Okay, so this is a value of c. Now it's going to affect now, because we used the value of m, which is wrong here, so it's going to be 5 over 2, guys, 5 over 2 here. All right, so what does it mean? It means our c is going to be affected. You see that? So it's going to be minus 1 minus 5 over 2 times 3, like this. All right, so like that it will make sense. So that means my c from my calculator, now it's best to use a calculator. This issue of not using a calculator, it affects. Okay, that's minus 17 over 2. So sorry guys for this. All right, that's your C, which is negative 17 over 2. So that means, therefore, my equation is going to be y is equal to mx. Remember, we said it's 5 over 2. We corrected this one. So it's 5 over 2x plus c. Our c is minus 17 over 2. So that's my equation. So I can leave this equation like this, or I can write, like I told you guys, there are so many formats that you're going to use. Y is equal to mx plus c. It's a format. Ax plus by is equal to, it's a format again. So you can play around this and write in any format that you want. Let's say you want to change this to another format, you can even do this. I can multiply because I've got the LCM here, which is 2. So I can multiply each and every term by what? By 2. Each and every term by 2. That's 2y is equal to, that will be 5x, and this will be minus 17. So I can even take all these terms to one side of the equation. 2y minus 5x minus 17 is going to be plus 17 is equal to 0. It's another, there are so many formats. So you can even leave your answer at that stage, is still one and the same thing. So guys, let's see another one. I hope we corrected that part, guys, that we just had. There we are given a curve. There's a curve that we have, which is of y is equal to 1 over 4x squared minus 1, and the line of 2y is equal to x plus 10, which intersect at the points P, A, and B. And O is the origin. Just O is just another point, which is the origin, guys. If you are talking of the origin, which means you are talking about the point O being what? Being 0, 0. That is at the what? At the origin, that is a 0, 0 there. So the question is to calculate the coordinates of A and B. Okay, first let's start with this, then hence show that OA and what they are perpendicular. Okay, let us start here by calculating the coordinates of A and B, which is the coordinates of B, because you're told that A and B, that is where these two graphs intersect. All right, and I told you guys, whatever graph that you'll be given, it's a quadratic and a straight line, it's a circle and a straight line, as long you are referring to the point of intersection here, you solve the given equations simultaneously, because you need to find the values of what? X and Y at those points. Okay, so that's what you simply do. You solve the given equations simultaneously. Which equations am I talking about? This equation of y is equal to 1 over 4 x squared minus 1, and this equation of 2y is equal to x plus 10. So how can I simply solve these two equations, guys? I can clearly see that here already y is the subject, so it's either I can just substitute y here in equation 2 so that I can solve, or I can make y to be the subject here on equation 2. Let's say this is our equation 1, this is our equation 2, because we want to solve simultaneously. So I can divide by 2 each and every term here. So y is equal to x over 2 plus 5. So that means I'm now having the same equation, but like this one, but this is like another way of writing this. So if y is equivalent to this value here, and also y is equivalent to this value, it means these two, they are equal, because it's y and y, they are equal. So therefore these two, they are equal. Like, you can't say y is equal to 2 and here you say y is equal to 5. It definitely means here also your y is supposed to be 2. So this must be also be equal. So you are going to equate these two, okay, like I'm saying. So you're going to equate 1 over 4 x squared minus 1. You equate these two, this equation, this part of a straight line, which is x over 2 plus 5, like this. So by equating, it's formulating an equation that you have to apply your basic knowledge of solving equations. And which are these basic knowledge that we're talking about? Talking of, you can maybe just collect this to one side of the equation. All right, 1 over 4x squared, x over 2 to this side is going to be minus x over 2. Here we've got minus 1 here, and this 5 to this side is going to be a minus 5. So it's minus 1 minus 5, which is minus 6, which is equal to 0. So this is a quadratic equation, yes, but let's see, guys, if we've got fractions here on our quadratic equation, because we know that our quadratic equation is supposed to be written in this format, yes, but avoid working with fractions, guys. Okay, so what am I going to do? Find the LCM of these numbers. That's 4, 2, a 1 and 1, which is 4. So we have to multiply this part here by 4, this part here by 4, this part here by 4. The LCM or the LCD of the given fractions, that's going to be x squared, and this will be minus 2x, and that's 4 here, 4 times minus 6, which is negative 24, is equal to 0. Any number times a 0, that becomes a 0 there. So we now have a normal equation that you can use. Yes, I know most of you like to use the quadratic formula. Yes, you can use your quadratic formula, but make sure that you apply it properly. Okay, but you can actually use the factorization. I know that the coefficient of x squared is 1 here, so what am I simply doing? Open two brackets, equate them to 0, insert x and x here. Then I know that I'm going to focus with the last term, which is negative 14, guys. From your factorization or level there, we can even go back there and have some recap on factorization. Okay, so what are the factors that you're going to have from minus 24, which are going to give us negative 2? That's negative 6 and what? And 4. If you multiply this, you get negative 24. If you add this, you get negative 2. So that's minus 6 plus 4 is equal to 0. So equating this bracket to 0 there, so x is going to give us 6, or x is going to give us 4. Equating to the 0, minus the plus is going to be a minus there, so x is going to be a negative 4. So these are the two possible values of x that we are obtaining, but we are calculating the point of intersection and we are solving simultaneously. We know that for this value of x, I have to find the corresponding value of y. So I'm going to substitute this x here into any of these equations, this one here or this one here, where I'm having y is equal to, I'm going to obtain the same answer. Okay, so substitute in any. So in this case, I'm just going to take this one, y is equal to x over 2 plus 5 from our equation 3, where we made y to be the subject there. So the first, when x is equal to 6, I have to substitute when x is equal to 6 there. That means y is going to give us 8. All right, we move on here. So this one was when x is equal to 6. When x is equivalent to minus 4, that means y is going to be minus 4 here over 2 plus 5, and this y is going to give us 3. So these are the 2 points that we are referring now, because remember, a point is made of x and y. That's a point. So you have the value of x and the value of y. The value of x here was 6, the value of y is 8, so that's 6, 8 as a point. The value of x here is minus 4, the value of y here is 3, that's a point. So these are the 2 points. So you can even name this a and this your b, because the question is for us to calculate. This is the question, calculate the coordinates of a and b. So just name. We don't know which one is our a, which one is our b, so you just name any, say this is my a and this is my b. All right, that's it. So that's how you solve the point of intersection. You solve the given equations simultaneously. All right, then hence, this is what is important, hence show, which means it's a continuation from this part that you just determined. Can you show that OA and OB are perpendicular? So okay, from our notes, guys, that I showed you that if two lines are perpendicular, if OA is said to be perpendicular to OB, it means the product of the gradients of line OA and the gradient of line OB should give us what? -1. So this is what we are supposed to prove. Once this is possible, then it means OA is what? Perpendicular to OB. So where is the point O? Remember, we are told that the point O is the origin, where we are given this O to represent the origin, and I told you that at the origin it means the coordinate is what? 0, 0. So we have got the point O. The point O is there, okay, which is 0, 0 like this. So let's start with OA. So the gradient of line OA, as we know, guys, the gradient, we say that's y2 minus y1 in this case. So we can just name our points. This is our x1, y1, this is our x2, y2. So y2 minus y1, that's 8 minus 0 here. So you've got 8 minus 0 over x2 minus x1, which is 6 minus what? Which is 6 minus 0 here. So that's going to be the gradient of line OA, which is going to give us something like 4 over 3, if I'm not mistaken there. All right, but just cross check with what you have. Your calculator, guys, like I said, please use your calculator. Please use your calculator. All right, let's move to OB here and find the same thing, the gradient of line OB, still the same equation, the same formula, y2 minus y1 over x2 minus x1. So this, now I'm referring to these 2 points, so this will be my x2, y2, so it's 3 minus 0 here, that's 3 minus 0 over x2 minus x1, which is minus 4 minus 0 here, that's minus 4 minus 0, something like that. So it's going to give us 3 over minus 4, of which 3 over minus 4 is same as minus 3 over 4. So that's what you have there. So now let's cross check. We have got the gradient of line OA, we have got the gradient of line OB. So we want to prove this is if it is going to give us a minus 1. So let's multiply MOA times the gradient of line OB. Okay, the gradient of line OA is 4 over 3 times the gradient of line OB is minus 3 over 4. So definitely here we obtain minus 1. So therefore that means OA is perpendicular to what? To OB. These two lines, they are perpendicular to each other. So that is the concept, guys. When the two lines are perpendicular, the product of their gradients from your notes is going to give us a -1. So that's actually what you have. So guys, I think it's a little bit clear and easier. So all you need is to work on as much questions as possible, like these ones where you are given that there's a straight line L which passes through the point 3 minus 2 and is perpendicular to the line. Okay, we are given the line. Find the equation of L, giving your answer in the form. Take note, guys, here we are given the format to use, which is y is equal to mx plus c. All right, so let's start here. We've got line L which is passing through a certain point and is perpendicular to. All right, this is it, guys. All right, the line L that we have got, let's just say this is our line L. All right, so this line L that we have here, it is perpendicular to a certain line. This is the line. Let's just say this is the line that it is perpendicular, or you can just, anyway, guys, you can even draw it here, but let me just, because I've already taken this space. All right, so these two, they are perpendicular to the line of, I don't mind like why the shape, or that I'm just indicating. All right, so this is the equation of the line, which is x plus 2y plus 1, which is equal to 0, like that. And we are told that the line L passes through a certain point, which is 3 minus 1. So this one is just 3 minus 2. It just passes through a certain point. So it's just an assumption. Let's just say this is a point where it is passing through 3 minus 2. We just know that this point is on line L. So what is important now is that we want to calculate the equation of line L. The equation of line L, this line. So what we only have on this line L is a point where this line is located. That is the only thing that we have. But we know that if we can have a point and a gradient, we can find the equation of a line. It's possible for us to do so. So we have to find the gradient. So where are we going to find the gradient? We are told that these two, they are perpendicular. And now we just proved that if two lines are perpendicular, their gradient should give us a -1. So that is what you're going to do. It means the gradient of this line L, okay, the gradient of line L times the gradient of this line. We don't know now this line that you're talking about, so let's just say M. The gradient of this line that we have, we must have -1. So we can know the gradient of this L if we have the gradient of what? If we have got the gradient of the other line. we can know the gradient of L if we have this. So this one, where are we going to have it? We know that I told you that if you can write your equation in the form of y is equal to mx plus c, m is the gradient. So let's take this equation and write it in that format. That means I have to make y to be the subject here. So that means 2y is equal to transpose all these terms to the right side. X minus x, 1 is going to be minus 1. So it's going to be minus x minus 1. But still y is not the subject because there's a 2 here. So divide by 2 each and every part. That means y is equal to this minus 1 over 2x can be written like this, minus 1 over 2, so that you can clearly see the part that is affecting x, okay? Minus 1 over 2 here. So that means if I can write my equation of a line like this, this is my gradient here. So that is the gradient of the line that we want. That is the line that is perpendicular to this line. Guys, here I'm using the multiplication. This is equal to, all right. So we are saying the gradient of L, which is the one that we want to calculate, times the gradient now of the line that we are given, which is this one, which is minus 1 over 2, should give us what? Minus 1. Why? Because these two, they are said to be what? They are said to be perpendicular. So if they are said to be perpendicular, that is the case. So for me to find the gradient of this line L, I simply divide by minus what? By minus half, both sides. So this can cancel. So the gradient of the line L is going to give us 2 in this case if we are to simplify properly. So we have got the gradient of line L. This is for line L. So if I have got the gradient of line L, which is the one that was stopping us to find the equation of line L, because we only given the point but we didn't have the gradient. Now we know that the gradient is 2. It means it's now easier for us to find what? To find the equation, because you have got the gradient of the line L, which is 2, and you also have a point which passes which this line is going to pass through, which is 3 minus 2. So simply apply your techniques, guys. Y is equivalent to mx plus c. Y is equal to m, which is the gradient. That's 2x plus c. So to find c, you now substitute this point. Let's just say this is x, this is y here. So y is minus 2. In place of y, you substitute minus 2. In place of x, that's 2 times your x here, which is 3 plus c. So 2 times 3, that's 6. Transpose this, that's minus 8, which is equal to c. That's minus 8, which is equal to c here. All right. So because it's minus 6 minus 2. Okay. So therefore, our equation will be 2x. We now go back here because we have got everything now. So it's 2x plus c, of which our c is what? Is minus 8. So that will be the equation now of the line, which is y is equal to what? 2x minus 8. So like I said, guys, these are the typical questions that you have, and all you need is to work as much questions. There we are given another condition where we are given the line L, which is given by the equation of 20 minus 3x, means the circle that is at that equation at the 2 points which are A and B, and then you're asked to find the exact length of the chord AB. Okay, so this is a circle, guys. So whatever that we know is that if these two are going to meet, we are going to meet at 2 conditions, which is at point A and at point B. So all you need is to find the length, the point A and B, then the length. So we said to find A and B, which is the point of intersection, I told you that you have to solve the given equations simultaneously. That is the case. All right. So which equations are we talking about? We are talking about the equation of a straight line, which is equal to, which is y is equivalent to 20 minus 3x, and also the equation of a circle, this one, which is of x squared plus y squared minus 2x minus 14y, which is equivalent to 0. Okay, so as you can see from this particular question, it's difficult for us to make y to be the subject, like what we did on that previous question where we made y to be the subject, then we equated the equation. This one is difficult. So what am I going to do? Since here on equation 1 already y is the subject, I'm just going to substitute 20 minus 3x in place of what? In place of y. All right, so that's what I'm going to do in this case. So let's just say this is our equation 1 and this is our equation 2. So I'm going to substitute equation 1 into equation 2. That's just like that. Okay, so that means in place of y, I'm going to substitute this. So this is going to be x squared plus this is y squared now, of which our y is 20 minus what? That's 20 minus 3x to the exponent of what? To the exponent of 2 minus 2x. All right, that's minus 2x. Here we do not have y, but this is minus 14y, so it's minus 14 like this, open bracket. You substitute your y here, which is 20 minus 3x, then everything you equate to what? You equate to 0. So just like that, guys, this is your equation now that you have to expand. So this one, you can actually use your mathematical techniques, guys. Remember how you expand x plus y squared, which is x squared plus 2xy plus y squared, which simply means that if I'm given x plus 3 squared, I'm going squared like this, I'm going to expand, which is x squared like this, plus I multiply this to x times 3 times 2, which is 6x plus 3 squared, which is 9. So I can simply do this or expand two brackets. Okay, so use your techniques also to expand this part. So here I'm going to have 20 squared, which is 400. Then I multiply 20 times minus 3x, which is minus 60, minus 60 times 2, which is minus 120x, minus 3x squared, which is going to give us a positive 9x squared. Okay, minus 2x, then here we expand bracket, minus 14 times 20, which is minus 280, minus 14 times minus 3, which is a positive, as we can see, which is positive 42x, which is equivalent to 0, like that. So definitely I have to collect like terms, the terms with x squared and x squared here, which is 10x squared. All right, then collect terms with x, which is minus 120x minus 2x plus 42. So if you add this properly, you're going to obtain minus 80x. All right, you move on to the constant, which is 400 here and minus 280 here, which is going to give us 120 equal to 0. All right, so remember, all I need is to solve for x, guys. So instead of working with complicated equations, reduce your equation, reduce this equation, and that's gonna be x squared minus 8x plus 12, which is equal to 0 here. So now you've got an equation that you have to solve by just factorizing or using the quadratic formula. Here the coefficient of x squared is 1, so I can simply open two brackets and focus with the last term, which is the constant, which is 12 here. So what are the factors of 12 that we are going to add? And they'll give us this middle term, which is minus 8. So let's cross check. We've got minus 6 and minus 2 here. If you multiply this, that's positive 12. If you add this, that's negative 8. So these are the terms, or these are the numbers that we are talking of: minus 6, minus 2. So therefore, that means our x is going minus 6 here is going to be a positive 6, or x is equal to minus 2 to that side is going to be a positive 2. So these are the values of x that must correspond exactly with the values of y. When x is equal to 6, therefore what is the value of y? I have to substitute this 6 into this equation. So here, substitute 6. Let's simply use this equation because it's the easiest one. So it's 20 minus what? 18, which is 2. So y is going to be 2. When x is equivalent to 2, substitute here. That's 2 times, which is 6 minus from which is 14. Y is equivalent to 14. Just substitute, guys, and obtain your values. So these are the 2 points that we are going to have, because remember, a point is made of x and y. So when x is 6, y is what? Y is 2. So I'm going to write these as points now. When x is 6, y is equivalent to 2. And another point, when x is 2, y is 14. When x is 2, y is 14. But these points, they are given names. They are not just points, guys. We are given that the other one is going to be called A, the other one is going to be referred to as B. So I'm just going to name them just A and B. Okay, so let's just, this is our A and this is our B. So these are the points which I indicated here, which I indicated here as A and B. But the question is not about the points. The question is for us to calculate the exact length of the chord AB. What is going to be the exact length? Now that you've got the point A and the point B, then we can now find the length. Remember, length of a line is given by this formula AB, which represents length of a line. That's the square root of, like I said, you can take whatever format, x2 minus x1 squared plus y2 minus y1 squared. So that's your x1, your y1, your x2, your y2 in this case. So even here you can write as x1 minus, it's still one and the same thing. So it's 2 minus 6 squared. Okay, plus 14 minus 2 squared. So that is the concept, guys. By doing this, we are going to obtain the exact value. Now, guys, you must have calculators which are suitable for A-level mathematics, guys. Not the DAL calculator now. At least working with Casio and so forth, all those calculators that you can use, because they can help you to simplify your answers in set form like this one. But because of too much light, you see, it's difficult for me to illustrate because there's too much light. But this is what you're supposed to have, something like that. All right, which you can actually use. I don't know which part that does not have light here. Yeah, something like that. So this one can even give you answers in exact form. This is the exact form, leave your answer in terms of square roots and so forth. So you must have something like that. Okay, so that's why I'm not indicating this, because of this too much light that is there. So that's why I say you must do there or using your calculator. Okay, so this is the length of AB, which is the length of what? Of the chord. All right, so that's it, guys. I want you to try these questions. I want you to work on these questions. Try, we are given the first question there, that is show that these ones are perpendicular, find the length of AC, then and so forth. Find the coordinates of the midpoint of AC. All right, then another question is to try this one, to find the length of a line joining the origin. Take note, we talked about the origin. I think I indicated this before. I told you that the origin indicates is what? It's 0, 0. That's the origin. Okay, so I want you also to try this question, and also the last one, which is this one, the points A and B, which are on a curve. They've got the coordinates, and take note here, the format, the equation of a straight line, you are given a format to use. So mind the format. Yes, you can work it in the form of, y is equal to mx plus c using that format. Okay, then on your final answer, you then interchange so that it can be like this. All I'm saying is that you can work it this way, then you rewrite your answer in this format. But when you were calculating, you were calculating using this formula. So it's still one and the same thing. All they are saying is that your final answer now, write in this format. All right, so guys, that's what we had on this particular section, working on coordinate geometry for A-level mathematics. That is particularly for the questions that we have. So all you need, all these questions, to try them and work on them. So that's it, guys, from Mason African Motives. Till we meet again.